Hello there, Mr. Sutton here, bringing you a lesson on polygon angles. In this one, we're going to find both interior and exterior angles in polygons. For our warm-up, we're going to see how much you guys remember about polygons. Now, if you were actually in class, we'd be doing this in a Kahoot, but you still need to fill out your guided notes, so we'll just do it manually here. So first off, the polygon definition. There were three parts to it. How much do you remember? A polygon is a closed figure, doesn't have any curves, and it has two sides per vertex. If it's missing any of these three things, it's not a polygon. A regular polygon, this is a polygon that is equiangular and equilateral. In other words, all the sides and angles are congruent. Like a square would be a regular quadrilateral. Same idea with all the other polygons. Now, convex versus concave polygons. A concave polygon has a cave in it. It has like an indent, a divot. A convex polygon doesn't have any caves. And special polygon names that you might not already know. 4 is quadrilateral, 5 is pentagon, 6 is hexagon. Just write down any of these that you didn't already know. Now, here's a few oddballs. 7 is a heptagon. 8's an octagon. We all know that. 9 is a nonagon. And a few other ones. For 10 sides, you've got a decagon. 12 sides is a dodecagon. And then if you have n sides, we just call that an n-gon. So in other words, if you have like a 13-sided shape, that's a 13-gon. 52-sided shape is a 52-gon, and so on. Now for some new material. Let's turn our attention to the sum of the interior angles of a polygon formula. So let's say we have some polygon, square obviously, and we chop it into triangles with diagonals. And let's say we have a pentagon and we do the same thing. And let's say we do the same thing with a hexagon, and we could keep doing this. The point is, how many triangles are we able to chop these shapes into? Well, the square, we chopped it into 2 triangles. Pentagon, we got 3. Hexagon, we got 1 more for 4. And you can probably see a pattern here. For an n-sided polygon, you can chop it into n-2 triangles using these diagonals. Now, why do we care? Well, each triangle itself has 180 degrees in it. Therefore, since all the angles of all the triangles add up to the same thing as all the angles of the actual polygon, 180 times the number of triangles, n-2, is going to give us the sum of the interior angles of the polygon. Now that we've got that formula, let's give it a little bit of practice here. Let's say we want to find the sum of the interior angles of a decagon and then a 36gon. So in either case, you're going to write that formula out. n-2 times 180 equals the sum. And then n is just the number of sides. So this is where you need to actually know what these shapes mean. 36gon is pretty obvious. A decagon, though, remember that's 10. So for the sum of angles of a decagon, we've got 10 minus 2 times 180. And I'll just get the calculator for this. Although we could at least subtract 10 and 2, right? So that's just 8 times 180. All right, now let's get the calculator. And 8 times 180 comes out to 1440. So 1,440 degrees is the sum of interior angles of a decagon. Pause the video and try out the 36gon. All right, all you had to do here was plug 36 in for n in the formula. So we had 36 minus 2, or 34, times 180, and use the calculator. So 34 times 180 gives us 6,120 degrees. For these next two problems, they're giving us the sum of the interior angles of a convex polygon, and they want to know what the original polygon was. So we can do this by working backwards. We're still going to use that sum formula, n-2 times 180 equals sum, or vice versa. But this time around, we're going to plug in for the sum itself. So we can write n-2 times 180 equals 900 for part A. And then we just have to solve for n and figure out what the shape was based on the number of sides. So next step here, we're going to have to divide by 180. That's going to be 5. So n-2 equals 5. Adding 2, we get 7 for our n value. So we have a 7-sided shape. That is a heptagon. All right, pause the video and try this next one. Okay, let's see how this went. So we can write n minus 2 times 180 equals 3600. And dividing that by 180, use the calculator if you want. I happen to know that that's going to be 20. Adding 2 over here, we get 22. And man, if only we could remember the name of a 22-sided figure. Oh wait, that's just a 22gon. It gets kind of easy when these side numbers get bigger. They get less specially named. On this next problem, they're giving us a big polygon here, and all the angles except for one have been given to us. We want to find that missing angle. So how would we do this? Pause the video and see if you can figure out a strategy for tackling this one. All right, let's see if we came up with something similar. So first off, it would be nice to know how many degrees this is all supposed to add up to. So we have a formula for this. It's that sum equals n minus 2 times 180 formula. That tells you what the sum of the interior angles should be based on the number of sides. So here's our formula. And how many sides are we plugging in for n? Let's see, we got 1, 2, 3, 4, 5, 6 sides. So that's 4 times 180, which is going to be 720 degrees. All right, next, we should probably figure out how many degrees we've already got. So add up the angles and set it equal to the sum that you just found, and x has got to be in there too. So all of these added together. I'm going to use the calculator for this part of it. So all of those angles we've already got add up to 599. And if I subtract that from 720, I'm going to get x equals 121. We're going to shift gears now to talk about the sum of the exterior angles of a polygon. So let's say I have some polygon, and I've extended all of the sides so that I have a bunch of exterior angles on here. Now take note of the shape of each of these exterior angles. I am going to shrink my polygon a little bit, but I'm going to keep all of the angles the same. They should be the same if I've got the same polygon, only smaller size. So shrinking it down, take a look at all my angles. They're a little closer together, but notice, like angle 1 is the same shape, angle 2 is the same shape, and so on with the other 3 angles. I'm going to shrink this even more to the point where this shape doesn't really exist anymore. All that exists are the exterior angles. Again, take a look at my angle shapes. Angle 1, pretty much the same shape. Same with angle 2, same with angle 3. Although they look like they're in different places, they are still the same shape. So what do you notice about what these angles have to add up to? We could draw a circle around here. How many degrees are in a circle? You got it. If you shrink any polygon until only its exterior angles remain, you're going to see that the angles have to add up to 360 degrees. And this is going to be true no matter what the polygon is. No matter what it is, we can always shrink it so that these exterior angles form a perfect circle. So in general, the sum of exterior angles of a polygon is automatically 360 degrees. Given what we know about the sum of the exterior angles of any polygon, pause the video and see if you can find out the value of x in this problem. All right, you think you got it? So because we know exterior angles always add up to 360 degrees, we're just going to set the sum of all these angles equal to 360. Then we can solve for x. So we've got all of these being added up with 360 on the other side. So all those x's add up to 7x, and we've got 150 also on this side. Subtracting 150, that's going to be 210. And man, looks like we don't even need the calculator for this. Dividing by 7 is going to give us 30. For this next problem, they're telling us that each interior angle of a regular n-gon has a measure of 140 degrees, and they want us to figure out the value of n. How many sides does this n-gon have? So this one could be a little bit tricky at first if you're thinking about it in terms of interior angles, because the sum of the interior angles of a regular polygon could be pretty much anything. It's going to depend on how many sides you have. But what's a measure that does not depend on how many sides you have? Why, the sum of the exterior angles. So it's actually going to be much easier if you convert this into an exterior angle, and then compare that with 360. So how can we do that? Well, an interior angle and an exterior angle form a linear pair. They add up to 180. So if we subtract the interior angle from 180, that will give us its corresponding exterior angle, which in this case is going to be 40. So since this is a regular n-gon, we know that all the interior and exterior angles are exactly the same. So that means we have a bunch of exterior angles that are all 40 degrees. Well, how many of those exterior angles do we have? Just divide 360 by this exterior angle, and that'll tell us the number of sides. So 360 over 40, that is going to come out to 9. So this is a nonagon we're dealing with here. For the wrap-up, pause the video and see if you can answer the following 3 questions. All right, let's see how you did. First question, find the sum of interior angles for a regular quadrilateral. So we can use n minus 2 times 180, where n is going to be 4 because it's a quadrilateral. So that's just 2 times 180, which is 360 degrees. And this will be useful, by the way, for pretty much the whole rest of the chapter, which is just about quadrilaterals. All right, measure of one interior angle of a regular quadrilateral. Well, we know that there's 360 degrees total for interior angles, and there are 4 of them because it's a quadrilateral. So 360 divided by 4 gives us 90 degrees. And then what's another name for a regular quadrilateral? So you got to be careful here. A quadrilateral that has 90 degrees for all the angles, well, that's a rectangle. But since it's a regular quadrilateral, that means that all the sides have to be the same as well as the angles. So in this case, that is going to be a square. That's it for now. Until next time, this is Mr. Sutton signing off.